Hey guys. So I kind of been waiting for a little bit, and nobody's posted any questions for me to go over on 5.5 or 5.6. So I chose I'm going to go over 32 and 33, and these are geometric proofs. Okay. So on number 32, this is our setup. We're given that QT bisects SP. And then the opposite, SP bisects QT. So if you guys remember from class, the word bisect is cut in half. That's pretty much what the word means. So when they tell me that QT bisects SP, that means that QT cuts SP in half. And if it cuts it in half, that tells me that I'm going to have two congruent sides, SR and PR. Okay, and then if we use the second given, so that's one congruency statement there. And if we use the second one, SP cuts in half QT, that's going to give me my second congruency statement. And it's basically telling me that QR is congruent to TR. So that's two congruency statements. And then we just need to find our third one, so that way we know how we're going to prove these two triangles are congruent. And one thing that we learned from section 5.4 is that whenever there's an X intersection, these two right here, these two angles, are going to be congruent because they are vertical angles. Okay? So now if we go through and we write out our proof, so we can then say that the two triangles are congruent by side, angle, side. So if we start writing out our proof, we have our statements and our reasons. Okay, so now we can begin. First one is always the given information. All right, you can write that down yourself. Second one, I believe we are given some piece of information. So let me just double check that real quick. Definition of. Okay, so this we're actually going to do two steps in one. So we're going to write down number one and number two. So we're going to write down that QR is congruent to TR. And the second one that we're going to write down is that SR is congruent to PR. Okay? And both of those are for the same reason, because of that word right there, bisect. So it's going to be the definition of bisector. Definition of segment bisector, to be more precise. Okay. So then that takes care of the first and the second congruency. We need to fill in our third congruency. So our third congruency is that angle QRP is congruent to angle TRS. And that's because vertical angles are congruent. Okay, just about done. That takes care of 1, 2, and now 3 congruencies. So now we can say that triangle, I'm just going to use the same order, QRP is congruent to triangle TRS. And the reason is because of side, angle, side. Once you have all of that written down, you've proven that two triangles are congruent, we can then go back and say that angle P is congruent to angle S because of C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Alright. So I'll leave that up there for just half a second. I know you guys can hit pause, but still. The next one I want to do is the very next problem. We'll take a look and see what that one is, though. And we're going to draw this one out real quick. Okay. So here's my diagram. Okay. It's not 100% close, but it's close enough. Especially since I'm doing this quickly so I don't waste time. Okay. And the only information that we are given is that PQRS is a parallelogram. PQRS is a parallelogram. And then we are asked to prove that triangle RPS is congruent to triangle PRQ. Okay. So let's start off first with the fact that this is a parallelogram. So because this is a parallelogram, that tells me that these two sides are going to be parallel to each other. PQ is going to be parallel to RS. And it also tells me that PS is going to be parallel to QR. Okay. And that's important for me to know because that, as you can see in the proof, is one of the very first things. So because those two are parallel to each other, that lets me use, again, we did this last time we went over proofs, the fact that PQ is parallel to SR and PR is my transversal. These two angles are going to be congruent because they're alternate interior angles. Then those two angles are also going to be congruent for the same reason, just using the opposite sides of parallelograms. And then the last one is that anytime a triangle shares the same side, I'll just put two dash marks. PR is going to be congruent to PR because of the reflexive property. And then I can say that my two triangles are going to be congruent because I have an angle, a side, and an angle. So let's go ahead and let's start writing up my proof now that I've done my diagram. So I have my statements and the reasons. Reason one, always, always, always given. Now, it's a parallelogram and I'm given certain information, I still have to go ahead and write it down. So I'm going to write down that PQ is congruent to RS and PS is congruent to RQ. Sorry, not congruent. Parallel. Okay. And that's going to be a definition of parallelogram. Okay. So now that I've said that those two are congruent, now I can go ahead and I can talk about the angles. Or not congruent, but they're parallel. Keep saying that word. So now I can say that QPR, angle QPR is congruent to angle SRP. Then I can also say the other two angles. Angle SPR is congruent to angle QRP. And the reason alternate interior angles are congruent. Okay, so that takes care of 1 and 2. My third congruency statement is that PR is congruent to PR, and that's the reflexive property. Finally, now that you got all of them, you have all three congruencies, I can say that the two triangles are congruent now by angle side angle. So I can finally hit my proof of triangle RPS is congruent to triangle PRQ, and the reason is angle side angle. Okay, so as usual, I like to mark up the diagram first. It gives you a nice little visual of where you are going. Lets you know, did you hit all the marks? So my color coding is over here as well, letting me know that I hit all the marks that I needed to. So we're done with this one. Hopefully that was helpful. As always, stay healthy. See you guys soon.